If you might be stumped right now, let's just talk about number one. What can you multiply by the zero matrix to produce 4, 1? Nothing. Cannot be done. What's going to happen when you multiply it by a zero matrix? It's going to compress whatever the coordinate is back to its origin, which is 0, 0. All right. Have you already attempted number two? All right. So what can I multiply in order to get a 4, 1? Whoa, gosh, this lag is bad. I have an alternative method. Hardwire in. Let's see if that helps. Seems to be. All right, so anyone come up with something? Something. Wow, that was weird. Did you hear that? Let me ask you this. Does a matrix in the form of all 4 spots being a number represent any linear transformation that we have over there? No. What we've learned is we learned that a diagonal of numbers and a diagonal of zeros will produce a dilation. We've learned that as long as these are the same and these are opposite signs, it will produce a rotation. And then a combination of these things being multiplied by the same number, you can also produce a rotation and a dilation. Does this consist of that pattern? No. Had this been like a -1 on one of these, yes, we could probably have found some type of transformation that did that. But in this situation here, this is not possible as well. And I'll show you why later on once I show you how to do it, why I knew that this isn't going to be possible either without really thinking graphically. All right. What did y'all get then for the third one? So 0, 0, 0, 1. What can I multiply by in order to get the 4, 1 point? Nothing again. It again does not follow the pattern of these being the same number and these being the opposite number. Now, zeros do have that pattern because it is 0 and -0 are the same, but this diagonal here doesn't have the same number. Does anyone happen to know what will happen to this point right here? Like if I multiply by this matrix, what's going to happen to a point in space? Now, it's not going to be 0 necessarily. Well, what's going to be 0? The x. So therefore, any point in space, if I apply this, it's going to take it where? To the y-axis. All right. So this right here basically will take any point. So not possible. And will take point to the y-axis. All right. Any questions there? This is kind of analyzing, kind of getting our mojo kind of going here. But let's suppose we have a linear transformation represented by this guy right here. Does this follow our pattern? No. So our first instances say this is not possible as well. What if I told you that there is a one to choose from? And if I told you yes, then what would you try to do next? Probably guess some numbers in there until you finally got 4 and finally got 1, right? This is an introduction to a system of equations. We have a point here of x, y. That's the unknown that we're looking for. And we're going to call this guy right here L. So that L there is going to be whatever that 2 by 2 matrix that it tells me it's going to do. So here we go. I'm going to do 2, -1, 3, 1 times some random points that I don't know must equal 4, 1. Anyone have ideas on what X and Y could be? So basically, in a sense, 2 times what plus -1 times what will give me 4. And then at the same time, 3 times what plus 1 times what will give me 1. Close. 1 and -1, this will produce, there you go. 1 and -1 would produce 3. 1 and -2 will produce 4. And then 3 minus 2 will give me 1. Good job. That is the correct answer, which was, again, 1 and -2. All right. But of course, on a test, if I ask you this question and you don't come of it quickly like Caleb just did, you might be on this problem for a while. What makes math fun is there's always a mathematical way to produce this exact same answer. Now, before I get into the main stuff, because the rest of it is just examples of what I need to teach today, I want to backtrack to number 1. So let me backtrack to number 1 to show you why I knew this wasn't going to have an answer without knowing it geometrically. Now, we use what we knew, and geometry is all that we know about transformations. Can someone tell me what the area is of this matrix? Or let me rephrase this. What is the determinant of the 0 matrix? 0. How do you produce the determinant one more time? That would be finding the inverse, but you're close. It's still the same concept, but the determinant is the absolute value of AD minus BC. We use that formula to help us find the inverse. This is what we're going to be doing today as well. But for this question here, I'm just focused on the determinant. Now, why did I first ask you the question area first? What do I know about the determinant? It also equals the area, right? So in this case, this would be 0 times 0 minus 0 times 0, which gives me what? 0. Anytime the determinant gives you 0 for a 2 by 2 matrix, it is physically impossible to use that as a transformation to move a point to a certain value. All right. So that's how I was able to instantly look at these and know. Let's look at part 2 there. What would the determinant of this guy be? 0, because this becomes 1 times 1 minus 1 times 1, which is 1 minus 1, which is just 0. So instantly, I was able to look at this and go, there's not going to be an answer here either because the determinant is 0. Now let's look at that last one. What would the determinant of this one be? 0 again. This will become 0 times 1 minus 0 times 0, which will become 0 minus 0, which is 0. So once again, just trying to determine the determinant, I knew if there was even a chance to get an answer. So let's look back at this one. What's the determinant of this guy? Good. This right here would be 2 times 1 minus -1 times 3. In this case, 2 times 1 is 2, negative and negative and a positive. That all gives me a positive 3, which gives me 5, not 0. So instantly, I know there is an inverse. Now, let me teach you how to produce this inverse. This is our equation. It gave us our L. So let's produce our equation and solve for our unknown. So this now becomes 2, -1, 3, 1. We already wrote this down a while ago. But now instead of guessing what X and Y is going to be to produce this, I can actually take whatever this matrix is, now that I know it does have an answer, and I can go find its inverse. So recall, to find an inverse, I'll just call it L -1 for now for your notes' sake, is 1 over AD minus BC switch the D and the A, change the sign of the B and the C. All right, that's what you had to do on your test, and this is what we're doing here today. All right. Now, what I can do when we solve the equations, let's take 2x equals 8. How do you solve that equation? 2x equals 8. Good. But what you did is you actually divide it by 2 on both sides, right? You did 2x divided by 2. That canceled, gave you the 1x. And then you did 8 divided by 2, got the 4. So that's what we're going to do now. We're going to multiply by this said inverse on both sides of the equation. Now, what happens if I multiply L times L inverse? What's that going to give me? What is the original matrix and its inverse? Not 0. The identity matrix. And if I end up with an identity matrix and I multiply by an identity matrix, what's it going to do to that matrix? It's going to keep it the same. So if I take this left side and I was to multiply whatever the inverse of this guy is, this entire matrix will disappear. Mainly because it would become the identity, which would become that 1, which would just be left with the xy. But like in all equations, what I do on one side, I must also do on the other side. Now, here's the flip side of solving equations in Algebra 1 versus solving equations using matrices. If I had something like this, and this is completely random, you don't have to necessarily write this down. But let's say I had... let's go with x divided by 8 equals 2. How would you solve this? Multiply by what? 8. And typically when you did your work, you just multiply the 8 here and you multiply the 8 here, just like this, correct? I had one on the left, one on the right. You cannot do that with matrices. If I multiply the inverse matrix here on the left side, I must also multiply the matrix on the left side. All right. So with all that said, let's put it all together. Let's find the inverse to start. This is 1 over A times D. So that's going to be the 2 times 1 minus the negative 1 over 3, which gives me the 5. So I have 1/5. Do I need to show that part again, or are we good seeing it from here? So I got 1/5 because the AD minus BC produced a 5. We good with that? Now take that. Yes, go ahead. You didn't do the 1 divided by that? Yeah, so don't forget that crucial part. In the past, this answer's been super easy. And it's always been like a 1 or a -1 or a 2. So it's like super stuff. That is where we're going to be kind of going away. And these numbers are going to be getting a little bit harder, more complicated fractions. Go ahead. Yes, ma'am. You want to wait 5 minutes and let the rush go by? All right, so I'm going to switch my A and my D now. So this is going to become a 1 and a 2. Change the sign of that B and C. So now this becomes a 1 and a -3. We good with this? Now I'm going to save us some work. You would then take this, multiply it to the left side, because that's what the inverse would be, right? I could do this right here. If I just take this and I distribute it in, just like you did on the test, I would get 1/5, 1/5, -3/5, and 2/5. Correct? What do I already know about this inverse and this original matrix? What's going to happen here? It's going to give me the identity. So do I really need to multiply that to do all the work? No, I know that's what's going to happen. That's why I'm multiplying by the inverse and for the beginning. So your real work is really determine the inverse, multiply it to what you want it to equal. All right, so let's do that. So this is the 2. It's really, I know it looks like a lot of work, but I'm trying to explain every detail. But it's really just 2 steps. Find the inverse, multiply by what you're trying to get it to equal to. So here we go. on the left side. Since I did the left side on the left side of the equation, I must also have the L inverse on the left side of what I'm trying to equal. And this is very crucial. And here's another reason, and you'll be able to try when you're trying to do the math, if you do it backwards, you should end up with an incorrect statement. What size is this? Oh, man, slippery. What size is this matrix? A 2 by 2. What size is this matrix? 2 by 1. So I can take a 2 by 2 times a 2 by 1. Right? I can take a 2 by 2 times a 2 by 1 because the inner parts are the same. If I was to put the inverse on the right side, you now have a 2 by 1 times a 2 by 2. Can I do that? So hopefully, if you forget that the inverse has to be on the left side, when you get to the point of multiplying row to column, you realize you don't have enough numbers, and it's because you set it up wrong. So make sure it is a 2 by 2 times the 2 by 1. So here we go. So this is, again, 1/5, 1/5, negative 3/5, 2/5 times 4, 1. And just like in that lesson 13, when we had to do all these fractions and multiplication, remember, you can just multiply the numerator with these big numbers and then divide the result by 5. So in theory, this is really what you're doing. I'm going to pull that 1/5 back out. Again, the concept of this is to teach you how to do math without a calculator. Would you agree that this right here is the same thing as this? All I did was pull that factor that I multiplied originally right back out, right? So these are the same thing. If I focus on just multiplying this and then dividing by 5, does everyone understand that multiplying by 1/5 is the same thing as dividing by 5? Okay. Anytime you have a fraction which 1 over a number, it's the same thing as just dividing. So if I was to multiply by 1/2, it's the same thing as dividing by 2. If I multiply by 1/3, it's the same thing as dividing the result by 3. Right? So anytime you have a 1 over number, it's the same concept as just dividing, just looks like multiplication. All right, so with that said, if I was to do row times column, what's 1 times 4? 4. I'm going to do all this work here. You don't have to if you want to do some of it in your head. 1 times 1 plus 1. Oh, I forgot my 1/5 here. Sorry. And then row times column again. Negative 3 times 2. 2 times 2. Yeah, you're right. 2 times 1. 2. Come over here. I have the 1/5. 4 plus 1 is 5. Negative 12 plus 2 is negative 10. What is 5 divided by 5? 1. What's negative 10 divided by 5? I no longer have to guess the answer. I can now mathematically do the work. So one more recap. To solve these matrices, whatever this 2 by 2 that's given to you, find its inverse. Leave it like this. It'll make doing math a lot easier. Take this, multiply it to the left side of what you're trying to equal. So you get something like this. Do your row times column in whatever process. If you can do it all in your head, skip to that step. I'm okay with that. If you can do it all in your head at this point, you can skip straight to that one. If you can literally go 4 plus 1 is 5 divided by 5 and get to that one, great. But just know that this is the work that's being done in your head or done on paper until you get more comfortable. Go ahead. Because that was what it was part of the inverse equation. So originally when we did our inverses, we always distributed to get to this point. That's how we got here. What I did is I just factored that 1/5 back out to make it all the fractions, and I brought it in at the very end to avoid what stresses y'all out the most, which is fractions. Now, if you're good with fractions, do it all at once. I don't care. We're good there? So if you're scared of fractions, do it at the very last. All right. The rest of this lecture is just more practice. So let's practice this together to make sure we fully get this understanding. And I wanted to go through this process just in case I ran out of time due to all the technology issues that we at least shown the lecture. Now we can go through and just practice. Nothing more will be new today. Before I do move on to these exercise questions, is there any questions that you have for me on what we just accomplished? So 2 steps. Find the inverse, then multiply it by whatever you're trying to equal to. All right. Now, this was presented to you as a 2x2, and you were able to go find the inverse real quickly. I can ask the question as a system of equations. I know you haven't seen this since maybe Algebra 2, but this is a system of equations, and you're going to be asked to produce the exact same thing we already gave you in the previous question. So if I want to produce something, and that's what we're just going to do here, is just produce. We're going to show how the system can be rewritten as a statement about a linear transformation of this guy here. It gave you a little bit of starter. Let X be that XY, that random point that you don't know, and let B be the answer. Notice that is your B. Every time it will be your B. All right, so whatever you're trying to equal, that's your B. To produce the L that you need to look at this right here without X's and Y's. So 2 things are going to happen here. You need to make sure that it's XY, XY. They can try to trick you and do the Y first. You would need to switch it. All right, so if this was 5y plus 2x, I would need to rewrite it as 2x plus 5y. It has to be in what we call standard form, which is x, then y. All right, what we're going to do is we're just going to write all of the coefficients down. So this will now become 2, 3, and this will become 5, -8. All right, that is my L. So when I bring it all together, I have my 2, 5, 3, -8 times my XY equals my 4, -25. All right. Now, if you're unsure that I'm correct, how can I multiply matrices? Row, column. I could do 2 times X, which will give me 2X, plus 5 times Y, which will give me 5Y, equals whatever that's supposed to be, which in this case is a 4. So if you're presented with this, you are expected to be able to write it like this and then solve it like we did in the previous example. Any questions on setup? That's all you had to do on part A was the setup. Okay. Part B now says determine whether L has an inverse. If it does, compute L -1B, which would be my answer for XY, and then verify that it does work. How can I determine if there's an inverse? What do I need to do? Find its determinant. So let's do that. I'm going to erase this. Y'all obviously have it already. This way I have more room. All right, so when I had my L, which was 2, 5, 3, -8, to determine if it has an inverse, I need to find its determinant. So here we go. So let's do a little side work here. This will be 2 times -8 minus 3 times 5. Yes, sir. Yeah. 2 times -8 gives me 3 times 5. -16 minus 15. -31. You are already a negative and you went further back. I will say that is the most missed answer, mainly because what does our brain want it to be? Well, not just a positive, but we want it to be a small number. So we're going to go, oh, that's a 1 or a 2 or something. But watch out for those signs for sure. So we get -31, which is not 0. So that does mean it has an inverse. So let's get to work. So to figure out what L inverse of B is, this is now going to be 1 over -31. What is the new matrix here? Perfect. Again, switch the place of your A and D, change the sign of your B and C, times my B, which was given to me as 4 and -25. If you're wondering where those numbers just came from, it just came from part A. Go ahead. That's a B. Yeah, I try to rewrite it like that. Yeah. Right? So again, it's a little bit easier if you go ahead and just multiply this and then come back and divide by the 31 rather than doing it all together. So that's what I'm going to do. I'm going to write my 1 over negative 31, and let's do the math. Negative 8 times 4. Correct. Negative 5 times negative 25. Very good. Negative 3 times 4. 2 times negative 25. Now I'm ready to add those up. If you already did it, great. Negative 32 plus 125. Because a 2 by 2 times a 2 by 1 should give me a 2 by 1 as a result. You might have already done it. I did not. As your teacher, I want to make sure you saw every process being done potentially in your head. So negative 32 plus 125. Yep, 93. Yep. Because that would take away, you would have 7 left, 7 away from 100. Yep, okay. I don't forget where I was heading. Negative 12 minus 50. That's it. Negative 62. Good. All right, now I'm going to divide these by negative 31. What is 93 divided by negative 31? I love it when they come out as nice, clean numbers. Negative 62 divided by negative 31. Positive. There's your answer. Now, it does ask you to check it. That is not a requirement, but you could. You could check it into the formula. So let's just check it just to make sure. 2 times negative 3 would give me what? Good. And again, what I'm doing is I'm taking the original equation, 2x plus 5y equals 4, and I'm just back substituting it in. So this is just checking. You do not have to check, but if you're not confident in your answer, there is a way to check it. 2 times negative 3 is? 5 times 2 is? What's negative 6 plus 4? Negative 6 plus 10? 4. Good. Yes, sir, you can. All right. And then you can check the other one. It's the correct answer. 10, 10? Oh, okay. Any questions on that? How do we feel about this topic so far? It's just algebra base. The hardest part really is probably just this fraction here. But if you just treat it as a division problem, it's not so scary. Now, I will say you're going to get a lot of answers too that will remain as a fraction, but at least you're not dealing with it until you're writing it out as an answer versus having to do the work as you go through the process. All right, let's do another one. Make sure we have this process fully done. That's really all the rest of this lesson is. It's just more and more examples. Trying to trick you as best as we can. All right, so the path of a piece of paper carried by the wind into a tree can be modeled with a linear transformation as such, where the answer is 610. Write an equation that represents the linear transformation of this piece of paper. Basically, what they want you here is to do that LBX or LXB or LX equals B. Do that now. Write out the 3 matrices as an equation. Let's see if you can do that without me. And that's all you're doing on part A. It's just writing out this formula right here. LX equals B. All right, do we have the answer? All right, this is simply just going to be 3, negative 4, 5, 3. What does X represent? X and Y. And then my B was given to me as 6 and 10. So everybody can write out the equation. Okay. Now solve it. Do it without me for now. Solve part A in B. I'll rewrite it for those that might have left the class. Be ready to check it. All righty. So again, for starters, you want to do your A times D. So that's 3 times 3 minus your B times C. So that's -4 times 5. 3 times 3 is 9. -4 times 5 would give me a +20. And then 9 plus 20 gives me 29. All right. So I now have 1 over 29 time. Oh, slipped. What's this matrix going to turn into? Good. 3, 3, 4, -5. I got you. All right. And times that B, which is 610. Everyone's still good with this? All right. Again, avoid that fraction as much as possible. 3 times 6, 4 times 10, -5 times 6, 3 times 10. Before I go any further, we still good? Okay. 18 plus 40, 58. -30 plus 30. 58 divided by 29. Ah, love those clean numbers. 0 divided by 29. 0. There's your answer. Good? And just like all math problems, let's relate it back to the word problem that we originally had. This was a piece of paper that was carried by the wind into a tree. What do you think the solution 20 means? So again, piece of paper carried into the wind, landed at what they're calling 610. What would the 20 represent? Not necessarily. Not the slope. Anyone? So again, you have a piece of paper. It was carried into the wind. Its location landed at 6, 10. What does the 20 represent? The initial location. All right. So that 2, 0 would represent the initial location. Because remember, that's not how you spell it there. Location. When we originally started this process, we were trying to come up with a point that would end at this spot. So 610 represents where the piece of paper landed. So you could have said it landed, up 6/10 from wherever the tree was located, or from the origin itself in space. But the XY is the point that's being moved. So very good. Initial location. Let's do some more to make sure we fully have it. We still got about 3 minutes left in class, so we can definitely do another one. All right. So do part A. I'll give you about 2 minutes, and then we'll check it. And if you're really good, try to do part B as well. Just an FY, you will not get a pretty number on part A. So if you're getting an ugly fraction, you did it right. What do you have to do first there? I see some faces. Is the first equation good? Is the first equation good? Remember, it has to be in standard form. How do I fix this one? Not -1, minus the 3x. The x is on the wrong side. So I want this as -3x plus y equals 1. Now it's written correctly. Now you're able to produce your matrices to solve. I told you that's what they'll try to do to trick you. And so I know we have about 1.5 minutes. So what would the L be? 3, 1. If there's no number there, there's an imaginary 1 located there. This would then just be XY. What would my B be? 1, 1. Very good. You enjoy the rest of the day, guys. We'll continue this discussion tomorrow.